great change, finally. So the topic of our session is making marine renewable energies a competitive and reliable option for clean energy supply. I will start just by making a brief presentation of our speakers, and then each of them will make a short presentation, and then we'll have some time to discuss at the end. So I will start with Emilio Nieto Gallego, General Manager of the National Hydrogen Centre in Spain. Bruno Miguel Pacheco Correia, from the Oceanic Platform of the Canary Islands. Carlos Pinho, Business Development Manager for the Blue Economy at INESC. And then finally we have José Oliveira, Floating Wind Technical Project Manager from Ørsted. Well, let's start with the first one. Yes.
Hello, good afternoon to everyone, and thank you for the organizers and of course to the moderator, and overall thank you to all of you, because to be the last one is not good, because you have no time, you have to speed up quite good, and also you don't see a lot of different people. Once this was the lunch and the coffee break is very difficult, so I try to go quite fast, because as the moderator was explaining to me, all the presentation and the information he will be sharing and sending to all of you, and we have a lot of different transparency and a lot of different information to share with you, so you will have a we start trying to explain to you who we are and what we are doing. I mean, we are a national hydrogen center who is located in Spain. This is in Puerto Llano. Puerto Llano is a place who are 200 kilometers to the south of Madrid, and you can see there in the map. And we are, is like PLOCAN. This is my colleague who will be the next one. We are a public research and development and innovation consortia who are belonging to the administration, and we have, in our case, this is a regional government from Castilla-La Mancha, and the national government, in that case, is the Science and Education Ministry, who are own this building. And we are located in Puerto Llano. As I told you before, we are more or less between 60 and 65 people working there. The most of them are chemical engineer or industrial engineer working only in hydrogen and fuel cell, try to cover in the whole value chain. What this means, the whole value chain, you can see there in our strategy. We are working in the production of the hydrogen. We are working mainly in renewable hydrogen. We are not saying green hydrogen, because as you, all of you know, the Commission was pointing out that the nuclear energy will be also green. So always we are facing problems when you are talking about green hydrogen, and how to divide and try to differentiate how is the different color between the green hydrogen or the green nuclear energy. So we are talking about renewable hydrogen. One was produced. We are also having some labs working in how to store. One, you are storing how to use and try to again use the fuel cell in order to come back to energy again, and the different applications both in stationary and the mobility section. And in the corner, and this is not the less important to be in the corner, is the safety and standards, and also the cross-cutting issues that is quite important in order to inform like this kind of event to the rest of the people. And how we are doing that with these 13 labs, we have one lab for all the different lines you are seeing in our strategy. We have also some auxiliary installation like the PV panels from the source of the renewable energy. We have this is called efficiency building. We have here all the whole value chain of the hydrogen. We are the electrolyzer for producing hydrogen, and also the fuel cell for coming back again to the energy and using this energy in the building. And you can see also here all the different infrastructure in order to recover the heat. So we are calling efficiency building installation, and you can see also the hydrogen refueling station we have there in the sites. Some of the projects, before we are starting to inform you, one of the projects which is the main reason to be here, this is the ocean hydrogen. One of the projects we have is to store the hydrogen. This is a circular economy example. Is one project where we are combining the waste treatment in order to produce as most efficient as possible the green gas. And when you are having this green gas or synthetic gas, you are sending this mixture of the gases with the CO2 to a solid oxide fuel cell in order to produce the energy and the heat. And this is one project we are running, and now we are building the pilot plant in one part of Spain in order to treat different waste and try to give a solution, a technical solution for strange waste or dangerous waste. Another project is coming for ammonia. All of you know that ammonia is creating the new vector for store the hydrogen, and is more efficient than the hydrogen as such. And we have two projects, two European ones. One project is the WavEC one, that is located in order to work with the catalysts, and these catalysts are integrated into the ARENA one, where we are building the pilot installation in order to produce this green ammonia and try to validate the whole process. Another interesting project, in order to inform you, is to use the hydrogen in the ports, but it's not the use of the hydrogen as a fuel for the vessel. That is another different project. In that project, we are using the hydrogen in order to decarbonize the working area of the project, so the logistics part of the project. And you can see here we have some combinations. This is the port of Valence. This is the coordinator. In this part of the port, we are having the electrolyzer, the production facility of the hydrogen, and this part of the port is the loading and unloading containers area, where we are using the rig stacker and jack tractor. These are the machines who are putting and taking out from the vessel the different containers who are based on the hydrogen in order to decarbonize. And another important project, in order to inform you, is the tree generation. This is the Together project, where we are using the hydrogen and the renewable sources in order to install in the houses. This is an stationary applications. Another important project, this is another European project for using the hydrogen in the trains. We are working with CAF. This is a Spanish rail producer, and we are working in our center in order to define the powertrain, to produce this powertrain and install into the train. And also one important step of this project is also try to develop the different models in order to fill in the train. One issue is to fill 5 kilos or 30 kilos in a bus of hydrogen, but in a train this is between 150 and 200. So you need to think about how will be the size of the tubes, the pressure and the speed, and the different temperatures we are taking care. And another two projects, I think, is these are the last one. This is one important project. This is a smart grid developer for hydrogen. This is an Interreg Sudoe, and where Portugal here in Lisbon, in the university, there is one part of the installation in order to validate until the end this smart grid. And another interesting project for you, this is mining electromobility. This is to develop the hydrogen vehicles in order to open an underground mining in order to reduce the cost, overall the CapEx you are needed in order to make the ventilation of this underground mining. And coming back to the main topic we want talking today, this is the ocean hydrogen, and this project, as you can see here, is try to generate, store and distribute the hydrogen to be produced when you are combined offshore and wind technologies. The project is coordinated by Acciona. This is coming from a funding scheme of a national entity. As you can see here, we have all the different companies, and these companies should contract all the research bodies, because this is an obligation from this kind of fund, and we are subcontracting by one party in order to develop the hydrogen part of this project. These are the main challenges of the project. So the main challenge, as you can see, is we need to develop the different individual technologies, wind and offshore. We need to integrate them in order to produce the hydrogen. We are taking care how to store the hydrogen into, depending on the deep distance you want to have, is a different floating or gravity-based structure, and you can see some picture here. And also one of the main issues is once you are producing, how is possible to distribute? How is the logistic of this hydrogen? How is possible to store in the land, store in the sea? How is transfer between the ships, the trucks, or even some installation into the land? And you can see here the scheme. We are not having time in order to explain quite in detail all the different parts, but you can see there is a whole picture about how to be the best way to integrate and to produce the hydrogen into the land. Talking about TRLs, I mean, the question when I read this project to the coordinator is if we are having the validation within the port, how is not possible to say we are achieving TRL 7? And the reason is because the individual technologies are not integrating as a one whole project. So this is an individual technologies, and this is why the TRL maximum we have here is TRL 4, and once you are having more money, you will be integrated and achieving the final validation until the end. And talking about, and the last 2 or 3 slides, is what we are doing now, because we are a National Hydrogen Center, we are talking about and working in the hydrogen, so these are the main tasks that is developed by us. This 1.7 is how is possible to design and integrate the hydrogen production, transport and supply within the project, and you can see all the different conditions we are talking about. We are considered compressed hydrogen, we are considered liquid hydrogen, we are not having time in order to explain you all the different parts of the value chain. We are considered the energy vectors or the carriers from the hydrogen, the ammonia, as I told you before, and the other one is the liquid organic carriers that we are using also in order to store the hydrogen and try to consider if it's better or not, more efficient or more costly than the other parts. And the other 2 tasks, and this task it has been already finished, is how it's possible to define the different bunkering systems. As I told you before, we have different possibilities, port to ship, ship to ship, or truck to ship, in all the different systems I told you before. We are developing a hydrogen refueling stations, compressed systems, liquid systems, ammonia, or even the blending in the gas grid, or having also considered to develop a new tube, a new installation from transport the hydrogen, who is calling hydroduct. How will be the next? And the next steps is once we are developing and how to know the different system we have, is how will be the best one, and try to work in how to integrate and design the different transport between offshore and onshore, and how to scale up the system in order to have all under control, construction, logistics, and also the maintenance works. And I think with this kind of information, sorry it was quite quick because we are running out of time, so I am here for any question you may have. Thank you.
Boa tarde, buenas tardes, good afternoon. It's a pleasure to me to be here representing PLOCAN. PLOCAN is, as you already know, ICTS from Spain, but for your information, I'm Azorian, I'm Portuguese, I live in Azores, but I'm working to PLOCAN. And this is a challenge because working from Azores to a Spanish entity, we have to go runner and faster, sorry, to follow my colleagues from PLOCAN. But anyway, PLOCAN, it's ICTS, it's a platform. We have a test site in Gran Canaria, in Canarias Islands, and we have a focus. The focus is to be a player, a stakeholder in the ocean fields, in particular in the fields of energy and the fields of food production and sustainable food production, the blue protein. And I bring here a short video to show you what we have, what we do, and what we can be able to do in the next future with you, with your companies, with your entities. We have two big main facilities. One of them is this one that you can watch in the video, and another one is in our facility inland, also in Gran Canaria. We can say PLOCAN, it's an offshore multi-purpose platform. But for the people who don't know where is Canaries, it's near Africa. It's as we say in Canarias, we are a tri-continental platform because we link America, Africa, and Europe. And what we do, what PLOCAN do, and what PLOCAN can do. We design and deliver research and development and innovation service to all of the pipeline of the ocean field, and of course with the focus in development service for the sustainable use of the marine environment. Our focus is ocean. We also can say ocean is our home. And what kind of service we can do? Testing, demonstration of knowledge, transfer of technology, testing of business models. We also can be a good help in the studies of the energy transition, food security, aquaculture, and here we normally use expression, it's how humanity will put food on the table for all of us in the next years, and this is the main reason why the blue protein and aquaculture is very important in our mission, in the PLOCAN mission. And of course, we also work in the digital transition, and in particular, the way that we can collect more data. And because we also know that without data, we can develop, we can foster new models and new products. We can see here some more image from of PLOCAN. It's our first. Okay, no. The landside facilities and the ocean facilities. And of course, that's the map of Canarias. And in Canarias we have other challenge, because in Canarias we don't have water, and this is another reason that the ocean field and the production of energy, it is very important, because as you already know, the only way that we can have water in Canaries is with desalinization, and for desalinization we need a lot of energy. In a resume, we participate in several projects. Most of them are European funded projects. This is some examples related with this field of the renewable energy, production energy. We are in this area. We work in this area for several years, and of course, we try to follow and help the deploy of new solutions, and with companies and with other entities that can be players in this area. These are some data of these projects. I will be faster here. Some of them are very known by all of you, or by some of you, and this is one example of a project that we are trying to develop, a new concept of integration of production of energy, aquaculture, desalinization, and also hydrogen. And to finish my quick presentation, I would like to focus in this final. In the learning lessons of PLOCAN that we got in the last years. To do this better, we have to have more flexibility and speed in the public investment decision. We have to have a framework of regulation that can avoid us to be more efficient in our position. We have to be more collaborative between the public and the private sectors to either the collaboration among all the stakeholders, and of course, the last but not the least, we have to be more efficient in the socially acceptable of these new products and this new service. That's it. Thank you all. And this is
I will keep the time here so that I will not get lost. So once again, good afternoon to you all. I'm going to present the multidisciplinary synergetic ecosystem, and I'm going to start with INESC Tech, of course, but the takeaway message is not actually INESC Tech, is the transforming initiatives that I would like to present in the end. And we are not doing that alone, but we are doing that with a lot of partners, and WavEC is one of them. So I will start to present INESC in a brief. I'm going to present the C domain, some projects so that you can also understand what we are already able and capable of doing with our competencies, and then the transforming initiatives. So starting to present INESC Tech, for those that don't know, INESC Tech is an R&D institution. It's mainly located in the north. I'm going to present it right away. And it is located, the positioning in terms of the value chain or the knowledge chain is between the academic world and businesses. So we try to take the knowledge that is developed to the companies in terms of solutions that can be transferred to the market, and also bring the challenges from the market again to research. So this is the positioning. We are spread around the north region of Portugal in 6 cities, or 3 cities, 6 sites, 19 laboratories. I'm going to present some of them and how we can use this multidisciplinary so that we can actually solve problems that are posed to us from, for instance, from the market. And we also have a mirror organization in Brazil. So we are quite big. We are more than 800 integrated researchers, and we have contracted PhDs and non-PhDs, like myself, for instance, more dedicated to the business world, so to say. In terms of associated institutions, as you can see here, the main stakeholders that we have are public institutions, namely the universities. So INESC Tech is quite big. We have 13 centers inside, and they are all organized more like an academic world, so in terms of scientific domains. But that's not the way that we can talk outside. So in terms of external interface, we have what we call the technologies 4, and one of them, the one that I'm going to present, is Tech4C, the one that I'm working on. And there is a vision, there is a mission, because we are dedicated to technology development, but we are not working, for instance, in biology. We don't work with materials, for instance, so we partner with other institutions. In terms of the main innovation services that we can bring to the outside world, taking our competencies and capacities, we can range from optical and biosensors to broadband communications, data integration and management. We can also work with virtual and augmented reality solutions, and I'm going to present one short video about this. offshore renewable and multiple energy vectors, and this is why we are also here, and also robotic platforms, for instance, in terms of perception, navigation, data gathering, and so on. So I'm going to present now some examples of past projects that we have already developed. And we can range, like I said, from sensing and monitoring. For instance, in this case, we are trying to develop autonomous systems that can gather the data that we want and bring that data. They can stay there for longer periods, or they can do specific missions. And the idea is to couple these advanced sensing solutions to the, for instance, to robotic platforms or for the infrastructures that can be deployed at sea. The turtle is one example of a lander that can be deployed for a long period of time gathering this data. This data can be, this is a platform, so we can install all the payload that we would like to have there, that is feasible to be there, and we can actually get that data back in terms of, for instance, physical parameters, chemical parameters, biological samples, and so on. The PLOCAN is about extending the internet towards offshore, and this can be quite useful in scenarios where we don't have an infrastructure. We also developed robotic solutions that can be used, for instance, in dams. So it's a platform. It has a sense of characteristics that you can read there, but the main functionality is to have space for the companies or the scientists to deploy additional sensors. Also, the automated inspection and evaluation in terms of drones. We are not competing with, of course, with commercial companies. What we do develop is the science behind what can be a target or a customized solution for specific missions. That's where we are targeting our development. And this one is a case that I'm going to show a video later on, also to provide some confidence that we are able to work in complex environments. This one is a solution that was developed in an European project with big players in terms of mining. And the idea was to develop the eyes of a drilling machine that would be underwater. And of course, when you start drilling, you cannot see anything. And this is quite a challenge, so to operate this kind of machines. So this is the video, and this is the final demonstration of the project. As you can see here, this was a small test site. This is an open pit mine where we were developing this demonstration of the project. This is a 20-ton machine, so it's quite small compared to the original one. But as you may imagine, in this lake, it's impossible to have a clean vision, especially when you start drilling. So the idea was to develop a pair of eyes that would be before the installation or during the installation as well of the machine, so that the operators could be like we normally play a game, could be in this control room, controlling all the operations and see where to deploy the machine, what were actually the conditions before deploying the machine, what were the conditions during the mining operation, and actually enable the operator to perform their tasks. So this is a combination of robotic solutions with augmented reality solutions that can be in real time used by operators in the control room to control these operations. So this is the main message here, and the idea is to show that yes, the academy, and in our case in INESC, we are able to work and develop solutions for complex environments. How we do this, and like I said in the beginning, we have a lot of laboratories, multidisciplinary laboratories that can be used to this end, and I'm going to show you just a few of them. For instance, the laboratory of smart grids and electrical vehicles that can be combined with robotics and autonomous system laboratory that can be combined with the laboratory for the laboratory for computer graphics and virtual environments, and so on. So we can develop this by having the tools, the infrastructures available to develop these solutions and combine them all together. Now the transforming initiatives. So this is what INESC Tech is, what we have, and now what we are doing towards the future that can actually go to the title of this seminar. So one of the infrastructures that has been developed and it's already, or it's finalizing the first phase and is going to be open for the academic and business world is Tech4C. So this is a wide pool of resources in terms of operations. The idea is to have the means and the resources to take something, take a prototype and go to the sea and test it. So this is the first one. Another one that we are venturing with WavEC is the Aguçadora test site. It was already mentioned here, for instance, by Core Power. So this is a test site that has a lot of history in terms of previous projects that were developed there. And we are now, I would say, rebuilding and reopening this test site to all the initiatives and all the technology developers that would like to test their solution. So this is something that is going on. Another initiative that is starting, but it needs to be finalized by March 2025. It's the Hub Azul de Leixões. So this is one of the poles of Hub Azul, and we are doing this in partnership with different partners, as you can see. But this is just a consortium for building up. The idea is to have this open for all other entities that would like to test it in this ocean basin. The idea is to have an ocean basin where you can take a prototype, a skilled prototype, and you can test there in terms of waves, currents, the materials, and take this data out, correct the prototype, retest, and so on. Now, how does this whole ecosystem works together? The idea is to have the first ideas, the first prototypes in lower TRL levels and actually test them in Hub Azul de Leixões. We can test those technologies there, and when they are mature or when they prove that they can survive outside, they can be taken outside, so to test sites that can be, for instance, in Aguçadora, where we have the partnership, or other locations, and can be tested there. And we also have the means to take these technologies from one place to the other. So the idea is to have here a complete ecosystem of solutions or support infrastructures that can enable, for instance, the companies to test not only a complete platform, but also components, and actually create the reliability for the solutions that they want. And this is it. Thank you.
Thank you, WavEC, for the invitation. It feels always nice to come back home. So thank you for that. I'm here to present you Ørsted. Ørsted is maybe I'll just start by showing you this. I will be very brief. I know I'm the last one before Professor Sarmiento final remarks. So, and I know your attention span is probably already limited at this time. So I promise to be brief, sharp, and to the point. Ørsted is a global offshore wind operator and renewable energy operator, and we do have a footprint that goes all the way from America to mostly Northern Europe and APEC. It's a journey. It's a journey that started 30 years ago in Denmark with the first project with I believe it was 5 turbines close to Copenhagen, and it's not working. Anyway, when we started 30 years ago, we started developing the first projects of renewables energy offshore, and we started in the Northern Sea. We increased our scope and our portfolio, and we currently have projects in all those places. We do have nearly or almost 10 gigawatts of operating assets. We develop, we engineer, we execute, and we operate those assets. On top of those 10 gigawatts, we have probably, I don't think, maybe 15 to 20 gigawatts of assets under development in all these areas. We are very active in APEC, especially in Taiwan, again in Northern Europe and in the US. And now, now we are starting to look at floating. All these projects that you see in the map are fixed bottom offshore wind projects. We are now looking like our competitors. We are now looking at floating wind, and we see very promising pipelines in many places. We do have in Spain and Portugal. We do have a partnership with Repsol to look into the tenders that are coming in both countries. We do have a partnership in Norway as well, and we do have other interesting prospects in the Northern Sea, in the UK, and in Scotland. So Ørsted has been developing marine renewables for the last 30 years, and from that we learned a lot. We learned a lot, and we have this extensive experience. One interesting thing that we learned is that renewable energies at sea are a really good idea. They are such a good idea that we decided to divest oil and gas like 5 years ago and dedicate ourselves completely to renewables, and mostly to marine renewables. So that's how we like marine renewables. It's a way to scale up the production of energy in a way that onshore becomes very difficult. You can industrialize, you can build with scale, you can make economies of production that are impossible onshore. You can deploy 1, 2, 3, 4 gigawatts in a way that's not possible anywhere else. You have space, you have the way to create, you can bring bigger machines offshore. You have conditions that you cannot find anywhere else, and that's what makes marine renewables a part of the solution to decarbonize our economy. So the problem or the challenge with this. The problem or challenge with this is really how to deploy 10 gigawatts in Portugal, how to deploy 3 gigawatts in Spain, how to deploy 15 gigawatts in the UK. It's very difficult. Antonio was mentioning the number of floaters that we're going to need. If you need 10 gigawatts, if you want to have 10 gigawatts in Portugal, if you use 20 megawatt turbines, you're going to need 500 floaters. You're going to need 200 floaters in Spain. You're going to need maybe double that in the Northern Europe. It's a scale that was never seen before in terms of the birth of an industry. And when I say floaters, I could mention mooring lines, I could mention anchoring systems, I could mention dynamic cables, ancillaries, all the components of a floating project. The supply chain is just not there. You cannot deploy 10, 15, 20 gigawatts in 2030 without a supply chain. So how do we address this? How do we solve this problem? Well, first, we need to have stable frameworks, and we need to have a stable pipeline. The supply chain will not invest if you don't have a stable pipeline of projects. There needs to be certainty in the tenders so that the developers and the suppliers invest in all this in this new market. Having said that, it's a big opportunity. It's a huge opportunity to tap into a global market that will go all the way from US West Coast, US East Coast, Northern Europe, Southern Europe, Taiwan, Korea, Vietnam, Japan. It will be an immense global market surging. And the front runners, the first countries that will start developing utility-scale floating offshore wind farms will have the advantage of being the first mover. So that's the main message I have for you today. The birth of a new industry and a new supply chain is something that the local economies will benefit a lot from. If you are a front runner, you'll get access, early access to a market that is simply not there yet. So that's could be one of the main reasons that would be a big support for Portugal and Spain to enter the market relatively early, tap into this global economy of supplying all these components for floating, and thereby going forward in the next decades, be a global supplier and a global player in this industry. Thank you.
Thank you so much, José, and again to all of you for your presentations. And I think now it's time to check if there is anyone in the audience that has a question for the speakers. Okay, then I think we still have a couple of minutes, so I'll introduce one or two questions if that is okay. And I'll address this one to Carlos Pinho, but of course any of the other speakers are welcome to comment. But Carlos, I was thinking about one of the slides in your presentation, which has like a brief comparison between some of the features in Viana do Castelo and a Gossadora for testing projects. And as you know, and was mentioned this morning in a presentation by Pinho, the Director of Electricity Services at the General Directorate of Energy and Geology, there is a public consultation in place right now, and that will end by the end of December, more or less, or in the second half of December, about a new regulation, a government order that will implement a free technological zone for the development of ocean renewable energies off the coast of Viana do Castelo, I believe, where now we have the Wind Float Atlantic project. So what is your view on that? Do you think this is an adequate site, or do you think that there could be other alternatives?
A good question. Well, I didn't have the opportunity yet to read the public consultation, but the way I see it, we can go on two ways. One of them is making Gossadora, if it makes sense, to be also part or be also a free testing zone, and also be complementing somehow what is going to be open in Viana do Castelo. This is one way, because in fact the conditions that we have there, they can be quite similar in terms of resources. This is one alternative. The other alternative, depending on the conditions for the free testing zone, it can be complementary. So on one side, we have the ideas for developing new solutions with new materials, new components that needed to be tested first in laboratory. We are talking about lower TRL levels that can go up to 3, maximum 4. These technologies or these solutions, if they prove that they work, they will need to be tested on another scale. For instance, from 5 to 6, something like that. So in these cases, we may already have a first prototype that may not be so similar to the first one, that we need to test again in harder conditions. In this case, and depending on the conditions that are put into the free test zone, this is one possibility to move those solutions there, depending on the time that the technologies can be there, from the frequencies that they need to be substituted, and so on. And in that case, the free testing zone would be a more dynamic place for testing, in the sense that I can go there, I can test for 2 weeks, I can go back, rebuild, go there again. The philosophy that in the past was built around Accelera was different. So the idea of having a technology there is for longer periods. In that sense, the technologies that normally were tested there, they already passed those TRL levels, and in that sense, they were there for longer periods. So they were already screened for different development phases, and they passed those obstacles. So, and this can be, again, a complementary position from Accelera, the free testing zone, Abazul, or whatever laboratories that can be there, and the way that all this ecosystem can work together. Another alternative, again, depending on the conditions, we may also convert somehow Accelera as a more similar condition for the free testing zone. And the idea is to have, if possible, some management scheme so that for the outside world it can be easier or not to be tackling with different bureaucracies to enter in the free testing zone or to enter Accelera. So to having some kind of framework that would enable for the technology developer to enter in these testing facilities that could be deployed in one or the other site, depending on the screening that is afterwards done according to the requirements that they pose. So I can see these two possibilities right now without having yet the time to read it carefully. And even if I had the time to read it carefully, it also depends on the final, on the final rules that are posed to this.
Okay, thank you. So it would be, you were talking about a framework similar to that one that we have. I don't know if it's still in force, but it's not being used for the pilot zone of São Pedro de Mel.
Somehow. Okay. The idea is that in whatever solution we came to the end of the regulation that is built, the ecosystem is going to be reinforced, and that's for sure. So this is positive, I think, and yeah, I think that this can be a very good opportunity for Portugal, and also for all those that want to develop technologies here in Portugal.
Okay, thank you. Any of you want to comment on this topic in particular?
I think it's important to point out public and private partnerships. I mean, the last week I had a meeting in Spain, and there were a lot of different companies, private companies, who are it was some representative from the administration, and it was always asking for money. And the administration guys was saying, we don't have money. We can help you in order to set up some preliminary amount of money in order to start the projects, and also try to work with the safety and standards, and try to help you in order to go to implement this kind of solution you are talking about now. So this is a good way in order to think all together, that we have to work all together. In the last tables it was already mentioned. So we have a threat, we have a challenge, and we need to work all together in order to build. And of course the companies are companies because they need to earn money. The administration need to help the companies in order to be competitive and try to make the things happen. So I think this is a good example, and yes, you are making better than the Spanish government.
Okay, thank you very much. I think we can end it here. Thank you so much.